Welcome to all. I am Part-7 going to present about steam nozzle conversion and diversion problems. In the steam nozzle expands from 12 bars and 300 degrees Celsius to 6 bars with flow rate of 5 kg per second. Determine throat and exit area if exit velocity is 500 meter per second and the velocity at the inlet to nozzle is negligible. Also find coefficient of velocity at exit. Coefficient of velocity is the ratio of actual velocity of fluid at nozzle exit to the velocity at exit considering isentropic flow through nozzle. Here given the data of P1, T1, P3 and mass flow rate from the problem. C3 velocity at exit point 500 meter per second. Find A2, A3 and the inlet from steam table obtained from pressure at entrance 12 bar and temperature at entrance 300 degrees Celsius. From that we can obtain the data of H and S1 value, and throat pressure also calculated from the equation P2 by P1 is equal to 2 divided by n plus 1 power n divided by n minus 1. And from steam table pressure we know that P2 value as well, so that we can obtain the data from steam table HF2, HFG2, SF2, SFG2, VF2, VG2, and then from equation we can have S2 is equal to S1, so that SF2 plus X2 SFG2 also used to calculate the X2 values, the dryness fraction value, and then use molar chart. From the molar chart we can find the H2 value and T2 value, V2 value at the exit of the nozzle will provide H3, T3, V3 values, and the throat velocity if inlet velocity neglected. C2 is equal to 44.72 square root of H1 minus H2, and the throat area from continuity equation mass flow rate is equal to rho 1 A1 C1 is equal to rho 2 A2 C2. From that we can calculate the mass flow rate at exit M2, and where we can find out the area at the exit as well, and then exit velocity if inlet velocity neglected means that formula will be 44.72 square root of H1 minus H3. From that we can calculate the C3 velocity at the exit, and area at a exit from continuity equation M mass flow rate is equal to rho 1 A1 C1 rho 2 A2 C2 rho 3 A3 C3. From that we can calculate the A3 value, and then coefficient of velocity also calculated from C3 dash divided by C3, and then this is impulsive turbine problem. Here the impulse turbine of 1 megawatt has steam entering at 20 bar and 300 degrees Celsius, and steam consumption 8 kg per kilowatt hour. Steam leaves at 0.2 bar and 10% of heat drop is lost in over friction in diverging portion of nozzle. If throat diameter of each nozzle is 1 centimeter, then determine the number of nozzle required and exit diameter of each nozzle. Where we can see the given data values of power 1 megawatt, pressure 20 bar, T1 is equal to 300 degrees Celsius, And from the problem we can calculate the throat pressure. After that we can calculate the entropy value at exit. According the isentropic flow, S2 is equal to S1 value. From that we can calculate the dryness fraction value at exit X2 value, and then use the Molière diagram chart. We can obtain the H2, T2, V2 value, and then throat velocity. If inlet velocity neglected, we can calculate the velocity at exit. C2 is equal to 44.72 square root of H1 minus H2. Throat area from continuity equation, M is equal to rho 1 A1 C1 is equal to rho 2 A2 C2. From the continuity equation, we can calculate the mass flow rate of the steam. Here we know value of A2 C2 V2 used to calculate the mass flow rate and number of nozzle. The total mass flow rate is equal to power multiplied with SSC. The total mass flow rate obtained from these values, and the number of nozzle is also obtained from total mass flow rate divided by mass flow rate in one nozzle. From the equation we can calculate the required problem find out. And then the exit section is also know the pressure at 3 is equal to 0.2 bar. From the pressure value HF3, HFG3, SF3, SFG3 value, also VF3, VG3 obtained from the steam table. From the equation of entropy and enthalpy, like entropy S3 is equal to S1, so that we can write the equation like this: SF3 plus X3 SFG3, as well as the enthalpy H3 value we can write like this: HF3 plus X3 HFG3. From that we can calculate the H3 value. From the entropy equation we can calculate H3 value. The enthalpy equation will provide the H3 value. And exit velocity, if inlet velocity neglected, we can write the equation like this: C3 is equal to 44.72 square root of eta multiplied with H1 minus H3. From the equation we can calculate the C3 value. Area at exit is also obtained from the continuity equation. We already know the mass flow rate of the steam. From the mass flow rate of the steam we can calculate the area at exit section, where we know the rho 1 and C1 velocity. So from that we can calculate the area at the exit section. After calculating the area, we can find out the diameter of the nozzle. This is the way we have to calculate the diameter of the nozzle. Thanks for watching this video. The continuation will be next video. Thanks.